Most of the American casualties in Iraq and Afghanistan have been caused by improvised explosive devices. So the Department of Defense has some pretty massive research programs to find types of radiation sources that can counter, burn out, or jam the improvised explosive devices. So we have two major research programs which we're working on to address these types of radiation sources. The idea is that our very high power microwaves could either jam or completely burn out the electronics in the transmitting or receiving devices before our soldiers are put in danger. If we can achieve high enough power, it might actually be possible to burn out or even prematurely trigger the explosive in the IEDs. So this is the recirculating planar magnetron. There's two linear arrays of cavities that are coupled by recirculating sections, and the cathode is located in the middle and generates an electron beam. You can actually see the effect of the electron beam when it hits this output window. It does a lot of damage. So this is what's inside the recirculating planar magnetron. There are a number of microwave cavities, and then the electrons propagate past these cavities, and then as the instability develops, the electrons slosh in and out of these cavities, and that's how they transfer their energy to electromagnetic waves. And in our device we have two linear arrays, one on either side, and the electrons actually circulate around past both linear arrays, and that's the basis of our patent. This is the second project, which is the commercially available off-the-shelf magnetron, which is typically used for cooking bacon. This is what's actually inside the commercial off-the-shelf magnetron. So unlike the big cavities that we had over there, these cavities are very closely spaced because the power is lower, but it's still very high power. Types of these devices have already been tested in the field. Right now I think the size is a big limitation. So this is the control area for our million-volt accelerator that we use for the recirculating planar magnetron experiments. The aim is always to get something that fits in the back of a Humvee, so that gives you an idea of what the goal is, but we're not very close to that goal yet. There's another application, and that's vehicle stoppers, which could actually save a lot of lives, because one way that they stop vehicles now is by shooting bullets at them. It would be a lot more humane if they could just launch some electromagnetic waves that would shut off the electronics in the vehicle. It would save lives, and it would also make our soldiers safer. When you see interviews with some of our returning veterans who have lost limbs and suffered horrendous injuries from improvised explosive devices, that really motivates me to try to see if there's something I can do to defeat these type of devices that are causing these horrible injuries among our soldiers.